The history of science is the study of the development of science and scientific knowledge, including both the natural sciences and social sciences. Science is a body of empirical, theoretical, and practical knowledge about the natural world, produced by scientists who emphasize the observation, explanation, and prediction of real-world phenomena. Historiography of science, in contrast, often draws on the historical methods of both intellectual history and social history. The English word scientist is relatively recent, first coined by William Whewell in the 19th century. Previously, people investigating nature called themselves natural philosophers, while empirical investigations of the natural world have been described since classical antiquity, and scientific methods have been employed since the Middle Ages. The dawn of modern science is often traced back to the early modern period, and in particular to the scientific revolution that took place in 16th and 17th century Europe. Scientific methods are considered to be so fundamental to modern science that some consider earlier inquiries into nature to be pre-scientific. Traditionally, historians of science have defined science sufficiently broadly to include those inquiries. For the 18th century through late 20th century, the history of science, especially of the physical and biological sciences, was often presented in a progressive narrative in which true theories replaced false beliefs. Some more recent historical interpretations, such as those of Thomas Kuhn, tend to portray the history of science in different terms, such as that of competing paradigms or conceptual systems in a wider matrix that includes intellectual, cultural, economic and political themes outside of science. Science in the Middle Ages. With the division of the Roman Empire, the Western Roman Empire lost contact with much of its past. In the Middle East, Greek philosophy was able to find some support under the newly created Arab Empire. With the spread of Islam in the 7th and 8th centuries, a period of Muslim scholarship, known as the Islamic Golden Age, lasted until the 13th century. This scholarship was aided by several factors. The use of a single language, Arabic, allowed communication without need of a translator. Access to Greek texts from the Byzantine Empire, along with Indian sources of learning, provided Muslim scholars a knowledge base to build upon. While the Byzantine Empire still held learning centers such as Constantinople, Western Europe's knowledge was concentrated in monasteries until the development of medieval universities in the 12th and 13th centuries. The curriculum of monastic schools included the study of the few available ancient texts and of new works on practical subjects like medicine and timekeeping. Islamic world Muslim scientists placed far greater emphasis on experiment than had the Greeks. This led to an early scientific method being developed in the Muslim world, where significant progress in methodology was made, beginning with the experiments of Ibn al-Haytham on optics from c. 1000 in his Book of Optics. The most important development of the scientific method was the use of experiments to distinguish between competing scientific theories set within a generally empirical orientation, which began among Muslim scientists. Ibn al-Haytham is also regarded as the father of optics, especially for his empirical proof of the intromission theory of light. Some have also described Ibn al-Haytham as the first scientist for his development of the modern scientific method. In mathematics, the mathematician Muhammad ibn Musa al-Khwarizmi gave his name to the concept of the algorithm, while the term algebra is derived from al-Jabr, the beginning of the title of one of his publications. What is now known as Arabic numerals originally came from India, but Muslim mathematicians did make several refinements to the number system, such as the introduction of decimal point notation. Mathematician al-Battani contributed to astronomy and mathematics, while scholar al-Razi contributed to chemistry and medicine. In astronomy, al-Battani improved the measurements of Hipparchus, preserved in the translation of Ptolemy's Himagel syntaxis translated as Almagest. Al-Battani also improved the precision of the measurement of the precession of the Earth's axis. The corrections made to the geocentric model by al-Battani, Ibn al-Haytham, Averroes and the Maragha astronomers such as Nasir al-Din al-Tusi, Mu'ayyad Adi and Ibn al-Shatir are similar to Copernican heliocentric model. Heliocentric theories may have also been discussed by several other Muslim astronomers such as Jafar ibn Muhammad, Abu Mazhar al-Burki, Abu Rayhan Biruni, Abu Said al-Sijzi, Qutb al-Din al-Shirazi, and Najm al-Din al-Qazwini al-Katibi. Muslim chemists and alchemists played an important role in the foundation of modern chemistry. Scholars such as Will Durant and Fielding H. Garrison considered Muslim chemists to be the founders of chemistry. In particular, Jabir ibn Hayyan is considered by many to be the father of chemistry. The works of Arabic scientists influenced Roger Bacon, and later Isaac Newton. Ibn Sina is regarded as the most influential philosopher of Islam. He pioneered the science of experimental medicine and was the first physician to conduct clinical trials. His two most notable works in medicine are the Kitab al-Shifa and the Canon of Medicine, both of which were used as standard medicinal texts in both the Muslim world and in Europe well into the 17th century. Amongst his many contributions of the discovery of the contagious nature of infectious diseases, and the introduction of clinical pharmacology. Some of the other famous scientists from the Islamic world include al-Farabi, Abu al-Kashim al-Zahrawi, Abu Rayhan al-Biruni, Nasir al-Din al-Tusi, and Ibn Khaldun, among many others. Islamic science began its decline in the 12th or 13th century, before the Renaissance in Europe, and due in part to the 11th–13th century Mongol conquests, during which libraries, observatories, hospitals and universities were destroyed. The end of the Islamic Golden Age is marked by the destruction of the intellectual center of Baghdad, the capital of the Abbasid Caliphate in 1258. European intellectual revitalization of Europe started with the birth of medieval universities in the 12th century. The contact with the Islamic world in Spain and Sicily and during the Reconquista and the Crusades allowed Europeans access to scientific Greek and Arabic texts, including the works of Aristotle, Ptolemy, Jabir ibn Hayyan, al-Khwarizmi, al-Hasan, Avicenna, and Averroes. European scholars had access to the translation programs of Raymond of Toledo, who sponsored the 12th century Toledo School of Translators from Arabic to Latin. Later translators like Michael Scotus would learn Arabic in order to study these texts directly. The European universities aided materially in the translation and propagation of these texts and started a new infrastructure which was needed for scientific communities. In fact, European university put many works about the natural world and the study of nature at the center of its curriculum, with the result that the medieval university laid far greater emphasis on science than does its modern counterpart and descendant. As well as this, Europeans began to venture further and further east as a result of the Pax Mongolica. This led to the increased awareness of Indian and even Chinese culture and civilization within the European tradition. Technological advances were also made, such as the early flight of Elmer of Malmesbury, and the metallurgical achievements of the Cistercian blast furnace at Lascaux. At the beginning of the 13th century, there were reasonably accurate Latin translations of the main works of almost all the intellectually crucial ancient authors, allowing a sound transfer of scientific ideas via both the universities and the monasteries. By then, the natural philosophy contained in these texts began to be extended by notable scholastics skeptics such as Robert Grosseteste, Roger Bacon, Albertus Magnus and Duns Scotus, precursors of the modern scientific method, influenced by earlier contributions of the Islamic world, can be seen already in Grosseteste's emphasis on mathematics as a way to understand nature, and in the empirical approach admired by Bacon, particularly in his Opus Majus. Pierre Duhem's provocative thesis of the Catholic Church's condemnation of 1277 led to the study of medieval science as a serious discipline, but no one in the field any longer endorses his view that modern science started in 1277. However, many scholars agree with Duhem's view that the Middle Ages were a period of important scientific developments. The first half of the 14th century saw much important scientific work being done, largely within the framework of scholastic commentaries on Aristotle's scientific writings. William of Ockham introduced the principle of parsimony. Natural philosophers should not postulate unnecessary entities, so that motion is not a distinct thing but is only the moving object, and an intermediary, sensible species, is not needed to transmit an image of an object to the eye. Scholars such as Jean Buridan and Nicole Orsma started to reinterpret elements of Aristotle's mechanics. In particular, Buridan developed the theory that impetus was the cause of the motion of projectiles, which was a first step towards the modern concept of inertia. The Oxford calculators began to mathematically analyze the kinematics of motion, making this analysis without considering the causes of motion. In 1348, the Black Death and other disasters sealed a sudden end to the previous period of massive philosophic and scientific development. Yet, the rediscovery of ancient texts was improved after the fall of Constantinople in 1453, when many Byzantine scholars had to seek refuge in the West. Meanwhile, the introduction of printing was to have great effect on European society. The facilitated dissemination of the printed word democratized learning and allowed a faster propagation of new ideas. New ideas also helped to influence the development of European science at this point, not least the introduction of algebra. These developments paved the way for the scientific revolution, which may also be understood as a resumption of the process of scientific inquiry, altered at the start of the Black Death. Impact of science in Europe. The renewal of learning in Europe, that began with 12th-century scholasticism, came to an end about the time of the Black Death, and the initial period of the subsequent Italian Renaissance is sometimes seen as a lull in scientific activity. The Northern Renaissance, on the other hand, showed a decisive shift in focus from Aristotelian natural philosophy to chemistry and the biological sciences. Thus, modern science in Europe was resumed in a period of great upheaval. The Protestant Reformation and Catholic Counter-Reformation, the discovery of the Americas by Christopher Columbus, the fall of Constantinople, but also the rediscovery of Aristotle during the scholastic period presaged large social and political changes. Thus, a suitable environment was created in which it became possible to question scientific doctrine, in much the same way that Martin Luther and John Calvin questioned religious doctrine. The works of Ptolemy and Galen were found not always to match everyday observations. Work by Vesalius on human cadavers found problems with the Galenic view of anatomy. The willingness to question previously held truths and search for new answers resulted in a period of major scientific advancements, now known as the Scientific Revolution. The Scientific Revolution is traditionally held by most historians to have begun in 1543, when the books De Humani Corporis Fabrica by Andreas Vesalius and also De Re Revolutionibus by the astronomer Nicolaus Copernicus, were first printed. The thesis of Copernicus's book was that the Earth moved around the Sun. The period culminated with the publication of the Philosophiae Naturalis Principia Mathematica in 1687 by Isaac Newton, representative of the unprecedented growth of scientific publications throughout Europe. Other significant scientific advances were made during this time by Galileo Galilei, Edmund Halley, Robert Hooke, Christian Huygens, Tycho Brahe, Johannes Kepler, Gottfried Leibniz, and Blaise Pascal. In philosophy, major contributions were made by Francis Bacon, Sir Thomas Browne, René Descartes, and Thomas Hobbes. The scientific method was also better developed as the modern way of thinking emphasized experimentation and reason over traditional considerations. Age of Enlightenment. The Age of Enlightenment was a European affair. The 17th century Age of Reason opened the avenues to the decisive steps towards modern science, which took place during the 18th century Age of Enlightenment, directly based on the works of Newton, Descartes, Pascal and Leibniz. The way was now clear to the development of modern mathematics, physics and technology by the generation of Benjamin Franklin, Leonhard Euler, Mikhail Lomonosov and Jean-Le Rond d'Alembert, epitomized in the appearance of Denis Diderot's encyclopedia between 1751 and 1772. The impact of this process was not limited to science and technology, but affected philosophy, religion, and society and politics in general. The French Revolution of 1789 setting of bloody caesura indicating the beginning of political modernity. The early modern period is seen as a flowering of the European Renaissance, in what is often known as the Scientific Revolution, viewed as a foundation of modern science. Romanticism in science. The Romantic movement of the early 19th century reshaped science by opening up new pursuits unexpected in the classical approaches of the Enlightenment. Major breakthroughs came in biology, especially in Darwin's theory of evolution, as well as physics, mathematics and chemistry. The decline of Romanticism occurred because a new movement, positivism, began to take hold of the ideals of the intellectuals after 1840 and lasted until about 1880.